Uh, so I'll be giving some insights into some of the findings that came out of the research I conducted for my recently completed PhD. And the research itself resulted in a book which has now been published for the dissertation and will be released more widely by the publisher Springer in the first quarter of this year. And basically, as I mentioned last year, the book covers the research. It is a goes into the foundations of cybersecurity data science. There's a part where I interview 50 cybersecurity data scientists globally and then summarize the findings from those interviews. And then there is a chapter on best practices that came out of both the uh, academic research and the interviews. So uh, basically, this year, what I'd like to do is to go into some of the findings that were quite interesting from the research, which I didn't have time to go into because of the scope of the write up of the book. In particular, to talk about some of the adjacent methods and domains that these cybersecurity data scientists reported using and emerging trends and threats. I'll start today with basically a foundation. So we all are using the same terms. So cybersecurity data science may be a new term to some security professionals, and so I'll just set a foundation for some of the understandings. Um, I don't think we need to spend much time on the classical FUD, the fear, uncertainty, and doubt factor, except to say it seems every year that there's a very dramatic and well publicized incursion, and this year is no different, which is we have the SolarWinds attack, which was revealed recently, and unfortunately, we're still trying to sort out the details of how far this incursion has gone, and it is quite worrying. Um, I'll only mention this because it's yet another example that the traditional security profession, as it is under a great deal of pressure, and part of it is basically the sheer complexity and growth of the networks and the technologies that need to be protected, combined with limited resources and huge amounts of data. Complexity and alerts that come out of the infrastructure are becoming increasingly difficult to survey and to maintain. So data science offers potentially a number of palliatives, a number of approaches that can help to improve security posture and security assurance. However, it can certainly be said that not all security professionals uh, are enthusiastic about the prospects for data science in the profession. In fact, there's some doubt. I had some good questions last year. Well, what exactly is data science? And that's a very fair question, really, which is that there is potentially, and I think it's a fair critique, an emperor's new clothes aspect to data science. And it can be essentially its own fault to the respect that it's difficult to explain often to others what data science is comprehensively, because it's actually potentially a set of different things. It can be explained as an academic discipline, as a set of methods, as a profession. Certainly, there are many people employed as data scientists. It is a set of management techniques and as well a set of technologies. And certainly, it can be critiqued as a set of marketing terms, some of which are rather hazy. So I think it's not my goal to act as the defender of data science, except to take a very pragmatic approach, which I have done in the research and the write-up, which is to say that data science is a collection, a toolbox of you will, if you will, of techniques that can be integrated to help make decisions and help to glean insights from large sets of data, especially concerning complex phenomenon and complex systems. So when we talk about cybersecurity data science, again, from a pragmatic perspective, we can say simply it's the selection of some of these methods to apply to security goals to help assist security assurance and security stewardship goals using these methods available through data science. And I think that's very pragmatic. And we see a number of focused disciplines such as financial analysis and marketing analytics and operations research, where there's a focused domain where data science methods help those domains to make decisions and to become more efficient. So one of the models that comes out of the research is a pragmatic model of supply and demand, which is that data science supplies a number of techniques, and that these techniques are put towards purposes for making cybersecurity goals more efficient. So this ranges from network monitoring to improving the architectural design of security systems, and that these all serve the purpose of assuring against threats and incursions and vulnerabilities. So one of the main results of the research is that there are three main components that are involved in cybersecurity data science, which are data engineering, data management, the application of scientific processes using these analytical techniques, and then approaches towards encouraging cross-domain collaboration between data engineers, data scientists, and security professionals, which includes incentives and unified goals, so that there's working together to integrate these techniques to the benefit of everyone involved. So the particular findings from the research involved the defining particular aspects of each of these pillars according to the interview research that was undertaken. So a good example of this in action, because I'd like to be practical and to give a tangible example, there's a very nice case study using a Google Cloud technology for the New York City Cyber Command. So this is big data, cloud-based cybersecurity data science in action. And indeed, if you look at the case study, you'll see that indeed these three pillars of data engineering, data science, which involves scientific insight and processes, and collaboration are all aspects of this. So the technological engineering side, a scientific aspect to help gain insights, and then the human and organizational aspect. So I can recommend that. This brings us to the main topic I'd like to raise today, which is to explore some of the other findings in the research. In particular, I had asked the cybersecurity data scientists that I interviewed what other domains that they apply in their work. One of the reasons was to gain a better understanding of the particular techniques that they applied in their work, being that data science has such a broad toolkit of methods. The results were interesting and I think worth exploring here, which are that there were 8 particular domains that these practicing cybersecurity data scientists reported utilizing in their work. On analysis of the particular domains raised, it became apparent that actually they could be split into methods and disciplines, that actually half of these domains raised had to do with particular techniques, and the other half were more particular to a larger body of an academic discipline of that type. So I'll go through first the methods in order and give a summary of each one. The first one was deep learning, and this I think many have heard of, is a machine learning technique that's proven very efficacious, in particular in analyzing unstructured data, particularly audio and visual data. and it basically uses nested neural networks. And when feeding in a large data set with labeled examples of something that one is seeking to detect or identify, it develops a very sophisticated understanding of aspects of that target. Um, and so this, of course, has some potential applications in looking at complex cybersecurity incidents. And so there's already been some research on this topic, and it seems a very promising technique. One note to make is that one of the practicing cybersecurity data scientists had remarked that although this is very promising and we're seeing some early indications that are quite good, it's still a work in progress, that the best practices still need to be refined in this domain. And indeed, very large data sets are needed, and as well, labeled incidents or instances are needed to be fed in. And there's not every organization has access to labeled examples of attacks or incursions to feed readily into these algorithms to train them. So another one of the methods that was reported is network graph analytics. The fundamental mathematical aspects of this technique go back to the 1700s, and it involves the formal study of network dynamics, interconnections between nodes in network patterns, and it's applied in many different domains, including the social sciences. But for cybersecurity, of course, it has a very natural sympathy, which is that the substrate of the infrastructure that's being protected is largely networks and network oriented. So it has a very natural fit to studying cybersecurity phenomenon. One of the major principles and useful aspects of this domain is that there are formal statistical measures that can be derived from the study of networks and network interaction. So the degree of centrality or reach of a network, the strength between varying connecting entities on a network, be they users or devices. And so all of these can help us to qualify and quantify entities in attempting to study network dynamics. And therefore, it has had a prolific use in the domain of cybersecurity. And indeed, we've seen case studies here at FloCon on this topic. So another method that was reported was natural language processing and semantic engineering. So these are somewhat distinct, although overlapping. When we talk about natural language processing, what we are meaning is the analysis of unstructured textual data to extract out topics and themes and meaning out of that data. I've actually even applied this to analyzing log files, security log files. Although, of course, it uses up a lot of computational power to do that, it can also find patterns and find meaning in structured log files. However, the most common use is for looking at human readable content, so news stories, emails, and this type of content. And so this can be applied, of course, to find indications of threats, to look at thematic content in language. Um, and this also has a connection to the topic of semantic engineering, which is that, of course, we're familiar with a broad number of frameworks that are applied in security and assurance. And there's been increasingly work and research done on encoding such frameworks and approaches into what are called ontologies, which are formal representations of a knowledge domain. And that these are quite interesting because they can be encoded in such a way that computers can read them. So we can share methods for understanding context and meaning with automated computer-driven processes, which is very promising. For instance, to help to automate triage processes or decisioning in cybersecurity analysis and operations. So another one, which will likely not be very surprising, is the application of forecasting and time series analysis. So this is a very mature domain. So in particular in financial analysis and econometrics, some very well understood methods are used to study patterns over time. Of course, this is very useful in cybersecurity data because we're often looking at phenomenon that stages out over time, particularly attackers and threats, and increasingly so, are doing or staging their incursions over a long period of time. So it can be a very subtle signal that needs to be detected in data over a long period of time. But it's also useful to establishing a baseline, for instance, an understanding of what is normal versus abnormal in a network or in device or user behavior. Of very understandably an important and useful field. I also will mention that it is an excellent foundation for process mining, which is um, understanding patterns in processes. So be that an attack or be that the normal actions that are undergone by a device or a user. And so that these techniques can help to feed in and help us to understand processes and to better improve anomaly detection. So having covered these methods, I'll now go into these disciplines that were raised by these cybersecurity data scientists. And these embody more formal academic disciplines or even professional disciplines. And the first encompasses fraud, forensics, and criminology. And of course, this is a very mature domain, even going back to the 1800s. And one of the interviewees had mentioned that they felt that this was not deferred to or referenced enough in the work of cybersecurity, and that more could be done to derive out best practices. So, in fact, there is quite a lot of research in this area, so particularly in fraud analytics that could be cross-applied to security analytics. So, for instance, anomaly detection and finding obscure patterns. Often criminals want to be hidden. So there's a lot of research and best practices that can be applied from these domains and cross-applied in security. Another broad discipline that was raised, which is sort of aggregated because it was mentioned in several respects as bridging medical, epidemiological, ecological, and bioinformatics disciplines, which is the application of more biological and medical analytical techniques and statistical analysis procedures to the security domain. So this has some crossover, which is natural with topics like network analytics, and there's some actual more than metaphoric similarities between looking at things like virus dispersion and infections between these two domains that are increasingly useful. So one of the quotes that came up was that as the networks that are being protected are becoming increasingly complex, there is more and more resemblance to biological systems in some respects. So there is a natural sympathy that can be understood in applying and cross-applying some of the techniques in these domains to security. So another one of the disciplines raised was social and behavioral sciences, including economics and game theory. And well, this is quite understandable given that we essentially have quite a lot of social phenomenon that is occurring on networks, and particularly the behavior of attackers and also the behavior of users when they're using devices. It's helpful to have an understanding or formal understanding of the human element and to understand how principles such as supply and demand and such as the motivations of threat actors influence the dynamics and behavior of attackers. So one of the areas that also was raised was risk management, and I think this is, of course, no surprise, and there's quite a lot of research and writing on this topic. However, it is worth just to repeat that without some understanding of risk, the mission of securing networks is quite difficult, because we need to quantify and identify what assets need to be protected, and to have some method to conduct triage and to value the time spent on protecting certain resources and less other resources. So that's quite understandable. So that covers the analysis of these adjacent areas that are applied in cybersecurity data science. And there's quite a lot of connection once they're separated into methods and disciplines. There's quite a lot of connection between them. It's interesting, I think, to consider that the methods offer utility, which is they offer certain benefits and techniques such as pattern recognition and classification and diagnostics, whereas the disciplines offer some context for modeling and understanding deeper phenomenon. And that indeed, when we bring these two together, a perspective on techniques, analytical techniques, mixed with disciplines which frame models, we have a type of approach whereby we can classify use cases for cybersecurity data science, which is to say that if we look at the types of goals that we would like to pursue using techniques and methods, and the types of domains that we are analyzing, be they technological, network infrastructure, or economic resources, or behavioral aspects of attackers and users. It can help us to refine and understand particular use cases in this sort of matrix of conjoining these two perspectives. So to bring things to a conclusion, I'd like to make a last observation concerning some of the threat trends that were raised during the interviews. So there were 13 particular adversarial trends that were raised, and I categorized these. I'd like to focus in on those that overlapped with data science more particularly. One of the most common observations was that there was and a sentiment that and observation that machine learning was increasingly fair game for use in adversarial realms, and that this was both as an attack mechanism but also as an object of attack, which is that increasingly we're seeing the proliferation of machine learning driven and algorithmic driven systems that are governing many different aspects of infrastructure and businesses, and that these themselves are an object that can be attacked by feeding in poison data, by tricking these algorithms, and that should also be a topic of increasing concern. In addition, two other of these trends had some overlap. One was the observation that pen testing, for instance, was increasingly becoming automated through sophisticated software tools, and that there were indications that these were showing up in adversarial toolkits, and that indeed machine learning was also considered part of these toolkits, and that could equally be of benefit to adversarial actors. The final thing was an observation that it appeared that state actors were increasingly hiring data scientists. So all of this together combines, I think, to somewhat of a worrying perfect storm, in that it observes basically that the benefits of data science to defenders are equally, if not more, beneficial to attackers, which is that at a very basic level, machine learning in particular offers great deals of efficiency to the security domain, which is it can help to identify patterns in large sets of data, to identify anomalies, to automate expert decision making, to automate very routine tasks such as reconnaissance and scanning, and thus can be used equally for offense and defense. So the parting thoughts here, I think, are that this is worrying, of course, is the use of these techniques, tools, and methods on the part of adversaries, which who have an advantage in being able to innovate and explore, and a great amount of incentive in that respect. So the question then, well, what is the benefit on the defender side? And to make this tangible and practical, I'd like to use an example, which is to just ask a question: what is a user today? So this is something actually that I pose to many security professionals, and of course they'll first thing they do is they'll laugh and they'll say, well, the answer really is it depends, because we can give many answers to that topic. However, that's worrying, because essentially we're attempting to protect users and devices, and if we can't define these basic entities from a theoretical perspective and substantiate those definitions, then there is then we have somewhere to go, I think, before we can improve security posture. So, for instance, I might suggest that there could be more research and writing done on a theory of the modern user, and to maybe even say that the modern user is essentially somewhat of a cyborg, which is that we're now interacting with and through many different devices, and these devices host automated processes, apps that are sometimes interacting on our behalf autonomously, which are gathering information and transacting with cloud-based systems, and that these is a very complex ecosystem, so that there is a notion that the individual person who, of course, must sleep and uses a device and a set of devices at certain times actually has agents that are operating on its behalf, the person's behalf, and that we could do better, I think, to understand the patterns and nature of what is human and what is automated, and how these conjoin into an aggregate entity, in order to study that, to form theories, to test those, and through the results of that testing, to put in place better defensive mechanisms. And by this, I think more tangibly what I'm getting at is pattern identification and analysis that leads to behavioral models, which is a proposition for what could be considered normal for particular users, be they individuals or groups, and then through that understanding to have filters that are able to identify when a user, or cyborg user as it is misbehaving according to its normal parameters. So I'll just leave that with a very open thought, perhaps something to explore next year. But it is the result of some of the side findings from the research, and I hope perhaps might be of interest. And just to leave then to say that, yeah, basically the results of the research were that more science is needed in the security realm, and that data science can be a helpful mediator in that respect. It can bring data and bring methods for testing and diagnostics, and that I think that itself is very hopeful. So with that, I'll thank you, and I greatly appreciate your attention, and I look forward to any questions you might have.